Hey everybody, this is Larry, this is me going Q2 of the weekly contest 392, lexicographically smallest string after operations if constrained. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one I actually thought there were a lot of room for silly mistakes, but looking at the top of the leaderboard, people seem to do pretty okay. So maybe I'm wrong on that one, but that's why I was deliberately taking my time to be slow on this one, and maybe you should too. I think one thing about problem solving is that you have to know the things that you're good at, and also know the things that you're a little bit sloppy at, right? And for me, I knew that it's very easy to make an off by one on this one, so definitely slow it down, take my time, get all the cases right. Okay, so this one, it is going to be greedy. The reason why this is greedy is that you can think about lexicographically. What does it mean by lexicographically, right? Lexicographically is just that, it is lexicographically means that earlier in the string dominates everything else, right? Basically, if you have, let's, for example, spoiler alert, don't look. If you have something like A, Z, and they're all Z's all the way, but then just one B and A, it doesn't matter what the rest of the string is, as long as the first character is smaller, it is good enough, right? And the second thing is that they try to disguise the problem, which it's a nice change of pace if you ask me, with this constraint thing with K. But you can think about it as just making K moves, right? Because the distance have to be remaining less than or equal to K. So you can make any number of Ks or any number of moves as long as less than K, I guess, right? So that's basically the idea. So the idea here is that we just do it one character at a time, opting for the beginning and then one at a time to the end, right? Yeah. The edge case that you have to consider is that I forgot to mention this. Sorry, is that A and Z is you go to 1, meaning that you could go looping the other way around, right? Also in the same idea is Z to B and so forth. So that gives you a way to kind of go up. So if you're at X, you would want to go to A by only making 2 moves, right? Instead of going like X to W, I think, whatever, 1 minus and then all the way down. So this is basically the idea. And once you break it out, all the code is, to be honest, this code should mostly be the same, but I just kind of, I don't know, I didn't want to get too weird about it, so I kind of broke it into these 3 cases, right? One is that offset is less than or equal to 26 minus offset, which is to say this character is closer to A than to Z. What do you want to call it? Like the over loop, the overflow maybe to Z, right? But yeah, but this is basically saying that you could go to Z by going down, right? So, and in that case, then we just take the delta of either K or the offset, because the offset is is the number of characters it is from A going downwards. So that means that we subtract it. So we have a new character, which is that basically we mix it as close to A as possible, going downwards. We subtract K from the delta that we used, and then that is the character, right? Alternatively, okay, let's say this character is closer to ZA. I just call it ZA so that it's the looping around one. Maybe that's a little bit easier to understand. If that's the case, then there are 2 cases, right? Where if we have enough K to use, meaning like, for example, if the letter is, I don't know, W, but you only have 1 move, you're not going to convert the W into an X, because that's just strictly worse, right? So the idea here is that, okay, if we have enough K, then we do make it into an A, because it doesn't make sense to make it into anything else, really. And then we just subtract it, and then we append it. Otherwise, we don't have enough to get to A, but we still want to move this letter, because that's just the way it is, in a greedy kind of way. So then we just subtract it as much as we can. So even if it's Z, maybe not Z, that's a bad example. Maybe it's W. If you have only 2, which gets you to Y, but Y is a worse letter, so you just go back 2 letters from W. I don't know the letters of the alphabet backwards, so my apologies. But you get the idea, hopefully. And yeah, this is a linear loop. This is a linear space answer. So this is going to be linear time, linear space. Everything else is all of one, right? We just do, you know, like 4 or 5 operations each or whatever it is. So yeah. But yeah, that's all I have for this one. Let me know what you think. And yeah, you could watch me solve it live during the contest next. 2, 1, 3. All right, let's go. Wait, so okay. Constraint. Okay. Okay. Why? Because this is 2 and 2. Okay. Any number that you can get after some changes, such that. So basically, you're trying to make k changes. Oh, it's only 100. That's actually surprising. Did I prove false or? Yeah, you have to prove false. I mean, no, it's greedy, but okay, fine. Yeah, I don't think it makes sense in any way. Okay. I don't know. Sometimes I doubt myself, but I mean, this was pretty. Should have been straightforward, to be honest. But okay. How do I do it? Okay. This is just easy to get wrong, though. I mean, you have to be careful. Not that hard, but okay. This is the character, right? So, so you want to subtract. Okay, so if offset, it's going to be the cost unless we go the other way, right? Which is okay. So if offset is less than this, then that's fine. Then we always take it. Then we set okay. Okay, I guess if it's even equal to it should be fine. Okay, then we take that k here. Right, so then now it is C minus offset plus OTA. Okay. Delta is equal to min k offset. Okay, new C, let's just say. Okay, else if k is greater than or equal to 26 minus offset. So yeah, if it's Z, that'll be 1, right? Okay, sure. And delta is equal to min of k or 26 minus offset, and then we just do this thing. That's fine. No, this is not right. What we want is no, this is not right at all. Well, this is right. But the idea is off. Delta is always going to be, no, the new C is always going to be A. That's what I want. I'll have to convert this to a character. else, if it's not enough, then we still just tick this thing. Okay, if k is 0, then this will just go sometimes, and then it'll just delta 0. Okay, fine. Is this right? Minus delta. So we want to subtract 1. We don't need this. That's why it's not right. Yeah, okay. Is that? Alright, very possible to have a wrong answer. Okay. Whew, that was kind of a tough one. I don't know how people got it so quickly. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanation, or the reading problems. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.